Okay, I'm going to do a little project here as an example, and it's kind of like what you're going to be doing in the lab, but it'll give you a sense of what coordinates are used for. Okay, I've got a center line of a road, center line of the road, and I've got a piece of property over here. I'm going to make it a little bigger so I can make sure you can see it. Okay, there's a piece of property. There's the 4 property corners. This happens to be the center line of the right-of-way. The right-of-way is the property owned by the county or the municipality. Here's the road going down the center line of the right-of-way. Okay, and if you were on a real piece of property, that'd be the back of the curb. Then you got a little bit of grass, and you've got a sidewalk. That all is owned by the municipality. Then you've got your own property. And on that property, we're going to set this house. Okay? And the house has to go on a building line. And the house sits right here. So that's a big box. There's the big box that goes around the house. Okay? And I got dimensions. I get those dimensions right off the plans, okay? I look at the plans and I get all of those dimensions. And I come out and I'm going to set my instrument up, okay? And we can calculate this based on a set of plans and a set of drawings. I'm going to set my instrument over here. Okay, I got a nice spot. I can set it where I'm out of the way. No traffic can run me over. I'm not in anybody's front yard. And I'm going to lay this big box out. Well, the first thing I have to do is I've got to either get the property corners of the center line of the road control and use that to determine where I'm at. So the first thing when you use a total station is you've got to have reference points that allow you to figure out where you set the instrument up at. This particular project was one students did a semester or 2 ago, and we already figured that out. Okay, we'll be doing this in class. So my instrument is at this coordinate. So my instrument is set right here, okay? And this would be like a robotic total station. Okay, I look at some control. I push a few buttons on the instrument, and the instrument has a COGO problem, a program in it called coordinate geometry. And it figures out its coordinate position. So it knows where it's sitting now. And now I've got to put stakes in. Off of the drawing, I've been able to find the coordinates of the house. Okay, and those coordinates were this. Let's see, what did we have here? Let me make sure I got this right. Northerling, 1235, and okay. So this guy right here is at 1235. Let me put the coordinates there. I'm gonna actually put them inside the house so I don't have to run them over. I'm gonna call this 1, this 2, this 3, and this stake number 4. Okay, those are my 4 stakes. So when I leave the property, I'm gonna look back and I'm gonna see 4 stakes with ribbons on them that create the big box. And my coordinates for 1, 2, 3, and 4 are the following. My northerling for 1 is 1235. My northerling for 2 is 1275. Okay, that's my little northerling for those. My easterling for 1 and 2 are 1045. And my easterling for the next one is 1095. So that's the coordinates. This one is 1235, 1045, 1275, so that's 40 feet. If you subtract the 2, you're going to find out that's 40 feet. Same easterling. And then I move over in 1275, so 1275 is the 40 feet, and the 1295 is 50 feet. So my box was actually 40 foot by 50 foot that went around this structure. Okay? Now what we're asking is, given the coordinates of the gun and the coordinates of each point, how do we go about figuring out what dimension we need and what angle we need to turn to get there? So this gun is sitting. Let's say I got him looking due north. What I want to know is this. We're going to do one at a time. I need to know L, instrument to 1, length, was a distance from that gun to that point, and off of the northerly line, how far do I turn angle-wise to get so that the gun is looking right through that. Hopefully you understand what that gun's doing. If you got a robotic total station, it's turning all these angles by itself. You program them in. You have to have the brains to program them in properly. But once you get them programmed in, all you're going to do is have a little data collector. You're going to push a button, and it's going to turn, and it's going to line up so that the line of sight goes right through stake 1, and it'll hone you in by either words or noises to tell you when you are exactly on spot 1. So it has to do all this math. You have to have the brains to program it to be able to do that, okay? So if I was given that problem, what would I do? In my mind, I would do exactly what I just did a few minutes ago. I would form a triangle. Right there. That triangle has a height and a width. I need the diagonal. How do I find the height? This is north. I subtract the northerlings and I get the height. How do I get the width? I subtract the easterlings. So if this has got a north of 1183 and this has a north of 1235, that means this height right here is 1235 minus 1183.26. That's the northerlings, okay? The easterlings, this has a 974. This is at 1045. So this number right here is going to be 1045 minus I'm subtracting the easterlings. Once I have those two, don't I have two sides of a triangle? If I've got the two sides, can I figure anything out that I need based on those two sides? So let's go about it. I'm going to take 1235. 1235 minus 1183.26. Oh, I got to clear it. Excuse me. 1235 minus 1183.26. 51.74. Okay, Easterlings, take 1045 and subtract 974.78. 70.22. Okay, it looks like if I have this angle right here, that's theta 1, and if I have this length right here, I've got all the instrument needs to know to turn the angle and to find the distance by moving me towards it. So it looks like the length from instrument to 1 is going to be and I did this before. I'm going to check it and make sure I've got it right. I got 87.22 is what I figured last time, so let me see if I'm okay. What do I got? 70.22. Ah, 51.74. 2677 plus 49, 30.8484. And then I'm going to take the square root of that, and I screwed it up. 51.74 plus 49, 30. And I'm going to take the square root. Oh boy, I'm not used to this. Is Leger's calculator. It's got me in a circle here for a minute. 51.74 times 51.74. $49.30.8484. Okay. The square root of and that's what it is. Therefore, the length is 87.22 feet between those 2 points. So that's how far they're going to send me. And then if I take the arc tangent, theta 1 is going to be arc tangent of opposite over adjacent. So I'm going to take the arc tangent of arc tangent how do you get this to do arc tangent? It's got shift. There, I got it. Okay, I got it. 70.22 divided by 51.74, bracket, enter. 53.61. So if I was sitting there in the field, okay, had my gun looking due north, and I turned 53.62 degrees, I would look right through that point 1, and if I measured 87.22 feet, I would end up exactly at 0.1. And that's what I can do by looking through the gun, using a tape measure. I can also do it by triple taping. I can lay it out by triple taping. I've got a lot of different ways to do that. But if you have 45 grand, a robotic total station will do all the math for you. You just have to be able to program it to get yourself to that point. So let's do one more and see how that works. I'm going to get rid of a few little things here. I'm going to get rid of this and this. And I'm going to get rid of this and this. And now I'm going to go to 0.2. And 0.2, I'm going to do exactly the same thing, okay? Notice, once you do it once, it's just a repetitive effort. You just got to keep your data correct. So I'm going to go from here up to 0.2. I'm going to cross over to 0.2. And then I'm going to draw a line from here to here. And that's Li2. And this is theta 2. And hopefully you see what I'm doing. It doesn't change. And there's no formula. It's just looking at the picture. I'm going from a north 1183. Now I'm at 0.2 to a north of 1275. So let's take and do the math. 1275 minus 1183.26. That takes care of that length. Now I'm going from an easterly of 974 to an easterly of 1045. 1045 minus 974.478. And that is that dimension. Once I get those two, square them, add them together, take the square root, and you've got your length. So clear 1275 minus 1183.26. 1275 minus 1183.26. 9174. 1045 minus 974.78. 7022. This side. Take the square root of that, and if I did it right, you should end up with 115.53.